Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome to Pepperl+Fuchs Plugged In. Today I have Corey Akanzi with me. Hello, Corey.
Hello, Helga. How are you?
I'm doing fine. Thank you, Corey. Corey, today I think you brought with you two somewhat related pieces of equipment. Let's start out with the first one, which is a very exciting new product, a line of, or a family, I should rather say, a family of vibration sensors.
That's correct. We have the vibration sensors. Those are used for machine condition monitoring. And when you say machine condition monitoring, what you mean is you want to make sure that your machine is always running within its normal parameters, because you want to avoid any kind of downtime whatsoever, so you don't lose any productivity.
So I guess when our listeners hear vibration, it's sort of obvious what we're talking about. But can you talk a little bit about the types of systems and machines and machine components that can benefit from vibration sensing?
Well, basically anything that has a normal spin or vibration, any of those types of things can become unbalanced. You talk about a windmill where the blades are spinning because the wind is blowing. Obviously, you don't want something like that to go bad. It can cause all kinds of issues, and it can be very expensive. You have fans for industrial ventilation. You can use them on pumps because they can actually detect cavitation in the water or the fluid that is going through the pumps. Water turbines falls under that same type of use. There's, of course, motors, electric motors, or any type of gas or diesel-powered motors, and, of course, conveyors. You want to make sure that your roller bearings on your conveyors are still in good order so that you don't have any type of issues where it tears a belt or anything like that.
Okay, anything else? What about mobile equipment? Is this a topic for mobile equipment?
They can be used on mobile equipment. That's because the output from the sensor is an RMS value, which is an average over time. So if you have a motor or a hydraulic pump or some type of compressor in your mobile equipment that you want to monitor to make sure that it doesn't break down, it's going to continue to monitor the machine. But if you were to hit a bump for some reason, like let's say you have a garbage truck that's going down the street, it hits a pothole, it's not going to necessarily set off an alarm that says there's something wrong, because the RMS value, as I said, is an average over time, and the output that you get from the sensor is just a very small blip as opposed to a big shock.
Mm-hmm. So it's taken out as it performs this average calculation. Makes sense. But what I'm hearing is mainly you're proposing to use these type of products in stationary applications.
For the most part, yes.
Okay. Now, also there is this line which we call VIM. The VIM line is composed of a number of different units. Can you sort of tell me from low feature to high feature what type of products are part of this product line?
Basically, we have the VIM3, the VIM6, and the VIM8. There's the three different models that we're introducing. The VIM3 is going to be the only version that has an IO link output. The other two, all three of them actually will have analog output. And VIM6 will include explosion protection in some models, and VIM8 will have SIL2 protection as well as explosion protection optional on all their models.
So in some sense, VIM3 is let me call it basic version, and as we go up from 3 to 6 to 8, they become more capable in a sense.
In a sense, yes. Keep in mind that the IO Link version of VIM3 will also be able to report 4 different things at the same time. It can report velocity, acceleration, temperature, and crest all at the same time, where the analog versions of all 3 models will only be able to report velocity or acceleration while also reporting temperature.
Yeah, got that. And they make up for that, if you want to call it that, by having, as you said, the SIL rating and the explosion ratings.
And that's correct.
Okay, very good. So when someone wants to use this, what type of a product do they have to connect it to? So you already talked about IO-Link, right? That would go to one of our link masters. And the analog versions, are those current or are those voltage outputs?
So the analog version is going to be a current output. It's going to be from 4 to 20 milliamps of an output.
Okay, good. I think, Corey, principally, vibration sensing, while a complex subject, is ultimately is relatively simple. You see when a machine vibrates, when it's vibrating itself to death. So probably there's not that much more to say. Let me summarize it. And while I do the topics we discussed today, think about our 5 words. What do you want listeners to take away from today's conversation? So what we're talking about here today is the VIM 3, 6, and 8 product family of vibration sensors. These are used on all sorts of machines that have a normal motion that operators want to maintain, and they want to get warned when something gets out of balance because these systems can literally shake themselves to pieces. What is special is the VIM 3 offers an IO-Link interface. And via the IO-Link interface, there is a lot of data reported: velocity, acceleration, temperature, crest values, all of these things at the same time. VIM 6, VIM 8 have additional features like SIL rating, and also are rated for hazardous areas. And they also, if I'm not mistaken, have a slightly elevated temperature range. But that's just about it, I guess, right? Did I forget anything that's critical?
Nope, I think you got it all covered.
All right, then why don't you give us the 5 words that we should take away from today's conversation?
Well, the 5 words would be no downtime with vibration sensing.
Oh, that's excellent, because after all, vibration sensor is something we do use for condition monitoring, and condition monitoring is a requirement for the protection of a machine. So no downtime with vibration sensing. I like that. That's great. Okay, Kari, we're going to take a little break here. And after the break, we're going to come back and we talk about another exciting product, somewhat related, but yet different enough. Inclination sensing is our topic. See you in a minute.
Yep.
Welcome back, everybody. This is the second part of Pepperl+Fuchs Plugged In. Still with me, Corey Kunze. And Corey, I already mentioned it before the break. We're going to talk about our IMU F99 inclination sensor.
That's correct.
So tell us a little bit about this general type of product, because I think we also have a few other versions that have to do with acceleration and inclination and all sorts of related topics. So why don't you start with that, please?
Yes, we do have a family of products, inclination acceleration sensors. Inclination sensors will measure inclination angles, and acceleration will measure acceleration. But the IMU F99 combines the best of both worlds because it has a gyroscope and an accelerometer on the inside to measure both inclination and acceleration. It can also measure.
And why is that important? Why is that important?
Well, that's important because on mobile equipment, you can have a boom arm or some other type of machinery like a front end loader where you have the bucket is up in the air, and it will maintain that inclination angle without having any type of error under dynamic acceleration. So when you have dynamic movement, sometimes the inclination angle can come back as a false reading, but ours combines the two together to account for that acceleration.
So with this in mind, is it correct to say that our inclination only model is great in applications where there really is no dynamic effect, where things are moved to a certain angle and then they're going to be steady there?
That's correct.
Is that correct?
Yep, that's correct.
And similarly, the acceleration sensor, if all you care about is a system that's constantly accelerated, you need to know what the acceleration is. Then you would use that product.
And that's correct.
And so the IMU F99 is sort of the flagship out of that family. It takes all these values and makes sure that your inclination angle is not impacted by dynamic motion. After all, we all know that when you move something, you accelerate it, and therefore you could change the numbers that these sensors internally detect.
Yep, that's exactly right.
Okay, so is it then correct to say that the F99 is used only on mobile equipment?
It's used primarily in mobile equipment, things like earth movers, bulldozers and excavators, cranes, more so on a mobile crane, because you think about a mobile crane, you want to make sure that the crane is perfectly level. So the IMU will let the operator know when the outriggers come out and levels it, that it's perfectly level, and allow the machine to operate as long as the machine stays perfect level. It'll also give the inclination angle on the boom as it raises, and then as it rotates, it'll maintain the proper inclination angle through that type of dynamic motion, through rotation and acceleration up and down.
Okay.
Things like garbage trucks, you have a garbage truck has that loading arm where it grabs onto the garbage can and flips it over into the thing and moves down the street. You've also got farm equipment. Think about a farm. Sometimes that farm field is not perfectly level. It could be on a hillside, or there could be, different types of changes in the terrain. You want to make sure that your farm equipment, you're not extending an arm out while you're at a bad angle, because you don't want the equipment to flip over.
Yeah.
Same thing with fire trucks. You can put it on the ladder angle, put it on the ladder of the fire truck to detect the angle of that ladder. And there's like so many more applications. It's kind of hard to get into every single one, but I think that gives a good general idea of the types of applications that we're looking at here.
Okay, very good. Very good. So we've talked about the applications. We talked about why the IMU F99 is different because of this compensation mode. Let me try to summarize what we talked about, and in the meantime, again, you get to pick 5 words that you would like our listeners to take away from this conversation today. So the IMU F99 is unique in that it has the ability to detect inclination sensor under dynamic motion. And to do that, it has some additional sensors on the inside, a gyroscope, an accelerometer, and it takes all these things together to calculate out what the proper angle of inclination is, even though things may be moving at that model. That is different from pure inclination sensors or pure acceleration sensors that measure those numbers perfectly fine, but they don't care if something is dynamic or static. So therefore, an inclination sensor that doesn't do dynamic compensation should be used only on stationary systems. And I think that's about it. That's what I heard from you today.
Yep, that pretty much covers it.
All right. So I'm looking forward to your 5 words.
The 5 words for this would be inclination measurement while in motion.
Yep, I get that. Very good. Yeah, while in motion, I think that is the important part, why the F99 is really superior. Very good. Corey, thank you very much. Thanks for doing the show with me today, and thank you, everybody, for listening out there. Bye-bye.
Bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.